Welcome to Grapless. In this tutorial, I will create a simple game so you can understand how to use and program the game with Unity Visual Scripting. In a new empty scene, create a cube. Because we'll need to be able to see the cube in play mode, so position the cube in the main camera to get a good view. With the cube selected, go to the inspector and create a script machine and add component. We need a script machine, which is a component used to run a visual script. Select the New button to create a new graph. To keep our project organized, we need to create a folder for script. I'll title it Rotate the Cube. And the description is control for the cube to rotate. Select the Edit Graph button that appears in the component. Because we use the New button in a script machine component, the start and update events are already included in our graph. Right-click on the graph window background to open the unit context menu. Enter Rotate in the search bar. When we select a unit, detailed information appears in the graph inspector. I will connect the two units like this. Right-click on the originating end of the connector to delete a flow arrow. Select the play button to run our visual script. We'll see beads moving along the connector to indicate the flow. But nothing will be happening in the scene view, because we haven't changed the 0 values on the transform rotate unit to tell it how much to rotate. We will change the X angle to 1 and click play again. The cube will rotate in the X dimension, 1 degree per frame. While we are in play mode, change the X angle value to 5 in C# scripting. We can't edit code while it runs, but in visual scripting, we can. When we specify values directly in C# code, they are hard-coded. If you know basic programming, you will know variable. Now we will create it in Blackboard. Change all 3 values in the transform rotate unit back to 0. In the Blackboard and the Graph tab enters rotate, then select the plus button with type, select float. It's a floating point number, also known as a decimal number. For value, enter 1. Drag the double bar symbol into your graph. We'll create a getVariable unit with the graph kind of variable selected. Connect the output of the new unit to the X angle. Select the play button and we'll see the cube rotate in the X dimension. In the Blackboard, change this rotate value to 5, the connector will display a 5, and the cube will spin faster. Exit play mode. The value will revert back to 1, because 1 was the last default value you entered before starting play mode. Only inline values that are changed in play mode are saved. Object variables are the same as public variables in a C# component script. It's connected to the game object. It can be changed in the inspector when the game object is selected. Create it by selecting the Object tab, entering Rotate, selecting Float. Value 1. Drag that symbol into our graph. Connect the output of the new unit to the Y angle. We change the value of a rotate to 5 in the inspector. The value has also changed in the Blackboard. The Blackboard and inspector displays of this value are always the same. Change the rotate value back to 1 and notice the changes in the scene view and the Blackboard. Exit play mode. Rotate will revert back to 5, because 5 was the last default value you entered before starting play mode. The values of object variables are changeable in game view and scene view. The values made in scene view remain, and any changes made in game view are lost. Let's bring it all together. Take a closer look at how variables behave when scripts are used on multiple game objects. Now we duplicate the cube. Position the cubes in front of the main camera. It's the same graph, but there are different values on the connector to the y-angle, because each game object has its own rotate variable. Each cube has a different rotate value because there are separate instances of the graph running for each game object. When we exit play mode, all values will revert back to their defaults except z-angle, if you changed it, which is hard-coded into your graph. Let's start a new graph. Create script graph. A new graph will be added to the Visual Script folder. Name the new graph Rotate Speed. I create a capsule and add a new script machine component to it, using the same steps you used earlier. Drag the new script asset from the project window to here. Add the update event unit. In the Blackboard, create a new object variable. Type integer and value 45. Drag the new variable into graph to generate a getVariableUnit. It dim because it isn't connected to a flow yet. We need to know the length of time, in seconds, that each frame is displayed. It's available through the Unity API on a unit titled getDeltaTime. The graph now has the values we need for calculation. Let's multiply them together with the unit aptly named multiply. Connect the output to the x-angle input. Multiply unit turns orange, warning of an error. Select the multiply unit, consult the graph inspector. We'll see that the inputs to multiply are missing. Connect the output from the getDeltaTime unit to either the A or B input. Connect the getVariableUnit output to the other input on multiply. And the orange warning will go away. Enter play mode to test your Visual Script. Now we create an if unit. This structure tests a boolean, true or false, value and follows one flow if it is true and another if it is false. Break this connection by right-clicking at the starting point of the connector. Add a unit titled input, getKey. Select space. Add an if unit to our graph. Connect the flow of the graph from update to getKey, to if. If a unit has two outputs, true and false. We want the capsule to rotate when getKey sends true, connect the true flow to the transform rotate unit. When getKey sends false, The graph will do nothing, so leave the flow arrow at false unconnected. Save and enter play mode. Be sure to enable the Values button on the script graph window so that we can see the values flow from unit to unit in real time. We'll make the capsule move up when the user presses and holds the W with Vector 3. Select Get Key and If Units, then right-click and select Duplicate Selection. Select W as the key. Connect the flow from the false output to make sure if the user isn't pressing the space, the flow will proceed to check if they are pressing W. Create a new graph variable with a type of Vector 3. Unity provides some useful Vector 3. One of these is Vector 3, GetUp. Add this unit. The GetUp Vector 3 has a Y value of 1, but 1 Unity unit, meter, per frame would be an extremely fast speed. Let's multiply that by 0.01. Create a float literal unit with an inline value of 0.01. Add a multiply unit, and make connections so that we are multiplying GetUp by 0.01. Add a set variable unit that will set the value of the graph variable change pos to the output of multiply. Add a transform, translate. This unit transforms capsule by an amount called the translation. Connect the output value of change pos to translation. I got bugs because I lost rotate degrees per second. To fix it I just added it back. Now play and you will see when I press space the capsule will rotate. Otherwise when I don't press space the capsule will stay still and wait to see if I press W. When I press W it will fly up. Here we can directly connect multiply to transform, translate, but we created change pos for the next step. We could add moves in other directions by doing the same thing, duplicating the steps we did with the W key for up, but doing so would make graph large and unwieldy. The switch unit is a powerful branching method that replaces the long chain of if units in case you have more than two choices. Delete input get key unit that checks for a space the add input, get input string, to check for any key pressed, and outputs a string of that keystroke. Change the first if unit by switch on string, which will input that string and branch the graph's flow according to that string. Configure the switch on string unit. Enable ignore case. At options, select the plus icon. Connect the output from the space string to the transform, rotate unit. Connect the output from WString to the set variable that updates change_pos. Duplicate units for the W key, and add a new set of these units for S. You won't be able to create multiple inputs from both of the set variable units to the translation, so add a get variable, change_pos unit and make this the input to translation. Save and enter play mode. You can easily spot the bug unit when it is highlighted in red. When clicking on the unit we'll see the bug on the right. With this bug, I had to create a get variable unit instead of pulling from the blackboard as I did in the previous step. Now that you can understand the structure of a script, here's the basics of visual scripting in Unity. Please subscribe to the channel to watch more advanced videos. Thank you for watching.